Is it okay online? So today meeting online, class online. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. So, are you ready? Are you hearing me well?
Yes, doctor.
Okay, please say something. No voice, not good. Okay, one moment. I am preparing everything. Okay, now let me prepare. Okay, now it is ready. Now let me on. So another 50, 17, 18 students. Very good. So 51. Okay, it means satu lagi. So now let me first of all record. Okay, recording on. Now sharing. Registration. Okay, please. To registration. And we will start. Is it okay? Finish? I hope it is okay. Now let me go to the analysis chapter 4. Okay, before starting this, let me shortly discuss about the midterm exam. Okay, so I have the solution. So let me just show you my solution, and you can see your mistake. Actually, I am now focusing on the evaluating your paper and the exam paper. Okay, so because this is quite important. Okay, you can see how much mark is actually. So another 3 people. So let me start. Then later on, please let me know that before finishing, I will open the registration. You will do it. Okay. So now please look at the midterm exam. Wait. midterm exam. Okay, Q1 A. So actually, you almost none of you properly discuss about this set. What is this set actually? You see, the -1 strict. The -1 strict less than x and 1. Okay, what is this set actually? You see, you should discuss about the uh, admissible values of this function. Look, if x varies on this interval from -1 to 1, the half open interval, then this x square minus 4 is always less than or equal to 0, right? So if it is less than, then x square minus 4 is equal to, if it is less, minus x square minus 4. Or I can say 4 minus x squared. 4 minus x squared. Okay, now look, this function equal to this function. Now, x varies from -1, up to 1. What about x squared? X squared is here from 1 and including 0. Okay, it includes 0. So x squared minus x squared is less than 0, greater than or equal -1. So 4 minus x squared is from 3 to 4. Okay, so now you see, if now a set a is equal to what? Is including 3 and 4. It is an interval actually. So this set actually equal to this interval, and it is closed interval. So that's why after closed interval, we know supremum of A, maximum of A has the same value, which is 4. Infimum of A and minimum of A is the same, which is 3. Okay? Could you understand any questions from this? Do you have any questions?
No.
I hope no questions, right? Very clearly, I have shown that this A actually equal to 3 to 4 interval. So you see, some of the students draw the graph and show the 3, 4. Some of them wrongly shown, but actually this is a proper one. Of course, I have given certain mark. So that's why, since it is a closed interval, very easy to find supremum and infimum and minimum, infimum and minimum. Okay, done. This A is done. What about B? For the B, most of the students make mistake. Yeah, this one actually, many students try to solve properly actually, but still some of them not good. Okay, what we can do here, we just take these expressions 1 over A, 1 plus 1 over B, and open up. So we open up this Okay, it is equal, so 1 plus 1 over b plus 1 over a plus 1 over ab. Okay, and we know ab equal to 1. So it is equal to, so 1 plus 1 is 2 plus, now if I give common denominator AB, here A plus B. So AB is equal to 1. That's why it is 2 plus A plus B. You see, this expressions is equal to this. So if I substitute into here, so 2 plus A plus B should be greater than 4, or A plus B should be greater or equal to 2. Okay, now how to prove this one is correct? We know from this one, B equal to 1 over A. So I substitute A plus 1 over A is greater or equal to 2. If I give common denominator, so A square minus 2A plus 1 greater or equal to 0. And this one is A minus 1 square. So A minus 1 square is valid for any A, not only positive, even from A from R. For any A, this one is valid. Particularly, A is greater than 0, definitely it is valid. Particularly, for the positive, strict positive A is valid. Is valid. If it is valid for any A, and particularly A greater than 0, so then A plus 1 over A always greater than 2. Okay, not including 0, because here 1 over A. Actually, here I should put this condition. When I give common denominator, I should put this condition. So actually, this one is valid for any A except 0. Particularly, A greater than 0 is valid. So it means this A plus 1 over A for positive A always greater than 2. Whatever give value on this interval, for example, you can check for the test. So A equal to 1 over 2. 1 over 2. So in that case, 1 over A will be 2. Right? 2. So A is 1 over 2 plus 2 is always greater than 2. Equal to 1, even A equal to 1, A equal to 1. So 1 plus 1 is equal to 2. So also valid. So any value you can give the A, you can get the this inequality. Okay, so that's why. So this inequality is correct. For positive A, it is correct, and for the positive B as well. Because if A is positive, from this relation, you can see B is also positive. Okay, so that's all. Now question number 2. Is there any problem or question?
Doctor, if I prove by contradiction means I use less than, then I found that when it comes to power 2, it must greater than 0.
But you should say the assume or suggest. You should say assume, assume this inequality less than 4. Okay, this inequality you should, because in order to come to the contradiction, you should assume something. But without assumption, if you just go like this, it is not complete. But of course, I saw such kind of solution. I think that's yours. It's correct. But without assumption is not correct. Okay. Then at the end, you get the contradiction. Is also okay. Yes. So this is the direct computation. Yours is by contradiction. Is also okay. Yes. So that's why I take into account. But if you don't do say the assumption and just say contradiction, so where is your assumption? So it is not complete. So I will deduct some mark. Okay.
Okay, thank you, doctor.
Okay. Now I think the second questions. I think second question most of the students confuse. Some very few of you is got the correct answer of this. A, look, A is greater than 0. B is less than 0. Need to prove that A over B is less than 0. Okay, now look, actually this is very simple questions. If you know that the axioms, you just use the axioms. Look, A greater than 0 is given. B less than 0 is given. From here, I can easily say A greater than 0 because of minus B is greater than 0. Okay. Now, one more, A greater than 0. If minus B is greater than 0, minus 1 over B is also greater than 0. Because of what we call it inverse of the, if A is positive, 1 over A is also positive. So 1 over B is also positive. Now, there is another axiom. If two positive numbers, then product of two numbers is positive. Which is, this one I can say minus A times 1 over B or minus A over B. So now minus A over B is positive according to the axiom. Okay, so that's the proof actually. Unfortunately, some students make a lot of writing something, but not meaningful. And most of the students actually lost mark. Actually, it is 4 marks. Now, next B. Actually, B is also not very easy, but already we have the proof of similar problems. So here f function is a mapping function from x to y. Okay, x to y. And AB, these two sets from x, from the domain, subset of x. X is a domain of f. Okay, now how we prove that A is a subset of f minus 1 of f of A. Okay, the proof, in the proof, we will say x we take from A. Let x belong to A. Then, okay, when x belong to the A, what I said, f of x. So A is a subset of x. So now f of, when I act f function on the both sides, it is the element of f of A because A is the largest set, x is a element of A, so we are writing in the A. So if we act the f of x, it is the element of this. Now if I act inverse from both sides of this, it is also the element of f of A. But this f minus 1 f, we know it, they are inverse function, and it gives the x. So x belong to f minus 1 f of A. So I have proved it. If x belong to the A, it is the element of a right side function. Okay. Now opposite. If x belong to, on the right side, f minus 1 f of A, can I prove that x not belong to the A. So from here, x might be belong, might not be belong. No, this one I have to prove. Opposite. Okay. Now I have taken the x from this and act both sides of this. It will be the f of f minus 1. F of f minus 1 is actually equal to the identity operator. So it is a f of A. So f of x is an element of f of A. But from here, we cannot conclude that x belong to the A. Please, A might be in A, may not be in A, because here, what is the definition of f of x? F of x, actually f of A is a, or what you call it? It is all the value of the function such that x belong to the A. So you see, this is value of a function, value of the function, or all the values of the function f such that x belong to whole A. But here we have the f of x, here f of A. So ax might be to the A or may not be belong to the A. Actually, from here, I cannot conclude that x always belong to the whole set of A. Okay, so this part, so that's why what I did, I put this part, who got proper of solution of this part, I put 3 marks because this is the main part. So this one is small part and I put only 1 mark. Okay, so that's why if you did this part, you didn't lost the many marks. Is it okay? Did you understand? Left part is very clear, nothing problem. On the right side, little bit problem because f of x belong to the f of A, x not belong to A or belong to the A is not clear. But generally, by the definition, we can say, so this f of x takes value, all the values of x such that x belong to the A. Okay, it looks like x belong to the A, but because of f of x, you see f of x value, this is not x, f of x value belong to the f of A, not followed x belong to the A. Actually, may not be belong, not completely reject, but may not be belong to A. Okay, so this is the solution of the Q2. Okay, next. Is there any question? It is okay, huh? Okay, I think no questions. So next, the last questions, Q3. Okay, in the Q3, yes, I did one mistake, but that one I ignored. I didn't deduct any marks for. So because when I check, I didn't properly check this interval. So the small n belong to the capital N, natural number set, and we consider this interval. Okay, so it is like this, and I can say this is an 3 over n. Actually, I should put here 2 over n actually. So, but it is it gives the same solution. Okay, so when n belong to the n means a1. Yes, the 3 and 3 minus 1 2. This is not interval. This is not interval. So now actually if I want to make proper questions, so in this form I should say n minus 1. So 1 I should exclude, okay, from this from this. So currently I didn't do, and I ignore this. Okay, so now what we do, so question says this interval, the interval is closed in R. show that this union is not closed. Okay, the proof is very clear and proper proof. So I consider this AN. Actually, I will consider like this. K from 1 up to N. Up to N. So generally, I can say it is not from 1 from the 2 because the first one we ignore. So it is A2, union A3, union and etc. union AN. Or, so A2 is when N equal to 3, 3 over 2, and 3 minus 1 over 2. So 6 minus 1, 5 over 2. Union, right? It is union, yes. Union. When 3, it is 1. When 3 minus 1 over 3 becomes 9, 8 over 3. Union and etc. Union 3 over n, 3 minus 1. Okay, now if I add these two, you see this one comes first. 1, and which one is bigger? This one or that one? Of course, 8 over 3 is bigger one. 8 over 3. So if I add these two, I got this, the union. So union, next union is the 2, 3, 4. When 3, 4, 3, 4, 3 minus 1 over 4, 12 minus 11 over 4. Okay, union 3 over n and 3 minus 1 over n. Okay, now if you continue this way, you see, you will get, this is 3 over 4, smaller than 1, and 11 over 4 is bigger than this. So at the end, we reach 3 over n and 3 minus 1 over n. Okay, you see, it looks like the union of all finite interval actually gives the last interval. Actually, last interval is the biggest interval actually. Okay, now what I do, I will take the limit of an as n tends to infinity. Then it gives union. So n from 1 to infinity, an. It gives the whole union of this. Now from here, when the n increases unboundedly, 3 over n approaches to 0. But this approaches 0 means not including the 0. Okay? It approaches, but therefore it is like this. 3 minus 1 over n. N tends to infinity. This tends to 0. 3. And 3 is also not included. It can be reached. It can be reached when n tends to infinity only. It can be reached. Right? 3 minus n, this becomes 0, 3. Open interval. This one is open interval. So that's why it is said that each set is closed, but the union is not closed. This one is open interval. Open interval. That's all. So the last one, 3b. Here, very confusing, I think, many students. You see, what does it mean? This interval, minus 10. Okay. If I take out 1 point from this interval, it becomes like this, minus 4 up to 10 union 10 to 15. So it is actually the union of two sets. Okay. Now you can see this is open interval. This one also open interval. Now what about the interior, which is we had interior point interior of A. We should count all interior of A. Interior of A is equal to A. I cannot say A because here, sorry, here this one is closed. Sorry, this one is closed interval. Now interior of A is -4 to 10 union 10 to 15. This is the interior of A. What about second one? Accumulation. Accumulation of A. Accumulation point. Accumulation point, since it is an interval, you see, it is an interval, including the endpoint, so it is -4 up to 15, including 15 also. This is what we call it, all the accumulation points of A, -4, 15. Third one is what? Isolated. Isolated of A is empty set because there is no such kind of sets. Okay, so this is a BI. Now what about second one? Here, look, please pay attention. What is this actually? 0, 1 interval intersection Q. Actually, if you count this set, you see intersecting 0, 1 is a real number set. Q is a rational number set. So intersection will be such kind of X from Q, X varies from 0 to 1, not included. So it means all the rational number in the, you see, I cannot say this is equal to 0, 1. If I say 0, 1, so this is a real number set. No, so it is not equal to this. Okay, so it is all the numbers in the interval which is rational, So this is a B set. Now after identifying B set, what is the interior point of B? Interior point of B. You see, interior point of B, every point with the epsilon neighborhood must belong to the set. But here, since it is all the rational number lying in the interval 0, 1, there is no such kind of interior point, empty set. Okay, accumulation point. This is all interior point, accumulation point. Accumulation point, yes, accumulation point is 0 to 1 because all the set A plus A prime is a set of accumulation points. So it is the 0, 1, all the points included. Isolate points of B. How do you think? What about isolate points? Rational number is isolated point or not? We have the formula. Hello. What I said is correct. Isolate point is also empty. Isolate point is also empty. That's all. Do you have any questions? Because none of the point is isolate points. Because for the isolate point, this epsilon neighborhood with the epsilon neighborhood with intersection A should give only 1 point. Only 1 point. Doesn't give infinite. It gives a lot of points. So that is the answer. Unfortunately, many students fail in these very simple problems. Do you have any questions, suggestions, or misunderstanding?
Doctor, for 3A.
3A, okay.
Why is the interval is open interval? Why is 3 not closed? Or why is it open?
Which one is not closed? Interior point?
No, for 3A.
3A. Okay, 3A. Uh-huh. In the 3A, okay. You're talking about the 3A.
Yeah, it's from 0 to 3, right? Why is 3 not closed?
Actually, look, very good questions. This is a very good questions. Now look, I can explain very well. So look, so here 0, 3 over n approaches from the right side, right? And here we have 3, and 3 minus 1 over n approaches from this side. Look, if I have 3 plus 1 over n, then 3 is included. Because here you see, it is approaching from the left to the right. This one from the right to the left. Understand? If I say 3 plus 1 over n, then it is approaches from the right side, then 3 is included. Understand the point?
Yes, doctor, understood.
So here we are approaching to the 3 from the left, from the inside of the interval. So that's why the endpoint is not included. And here 0 also not included because we are approaching from inside. If from the outside, from the left to 0, then 0 is also included. Here, both of them are not included. Very good question. Get it point?
Yes, doctor.
Okay, I think the last question is nothing wrong and nothing problem. I hope you can understand, right? So that is the solution. Now, after checking, I will put my estimation in the pembelajaran. You can check yours with this one, but this one I don't put in the pembelajaran because this one I can use in the future. Okay, so that's why I will do change some changes, and in future I can use it. For the quiz, no problem. I always can renew. For example, in the previous exam, I just little change here, and this one I didn't change. Second question I didn't change because I know this one is very good questions. So that's why I cannot put the solution of my scheme in there. Is it okay? So today I have explained it everything, A to Z. I hope everything is clear, huh? Nothing wrong. Can I start the class?
Yes, doctor.
Okay, good. Thank you. Okay. So now let me at least start some from yesterday. I cannot start the new one. Yeah, very, very strange. Okay, I go. Then now we have the new last chapter. Actually, Miss Anna, this week is what week? 10th or 11th?
11th week, doctor.
Okay, if 11, and I hope we can complete the conversions because this is the last one. Sequences and convergence. Huh? So already I have explained it yesterday. Definition very clearly explained it. A sequence is a function whose domain is natural number set. A real sequence is a sequence whose range is in R. Yesterday I explained. And this is a real sequence is therefore we can, usually the sequence is denoted by xn, yn, zn, or an, bn, cn. Usually you see uh, sub n actually sometimes we denote it, like this. xn in the bracket, yn in bracket. This is the symbol which we can ignore. Also can. This one also sequence. So this is a notation. Now, this notation, actually, you see, this xn, I can say beta, not x of n. Actually, f of n is beta. It's f of n, because f is a function, n is a, so this one is a function. This one is a function. For example, yn, I can say g of n, also function, also function. So whose domain is in R, in n, natural number set, range is a real number, Okay. So the note that the sequence, you see, this is a notation xn n start, because you know showing this way is more complete, because if I say just xn, x sub n, actually n varies from where? Maybe from one, maybe from two, because later on you will see there are many cases we can skip or add or reset. So note that the sequence is not the same as the set of xn n from y. This in the bracket, which is commonly denoted by the sequence of real numbers, okay, or xn. Actually, this one is x1, x2, and etc. If like this, for the x1 is an ordered list, xn is the ordered list of the values of the function x, some of which may be repeated. Okay. So now there is two type of notations. So in the bracket, xn, n from n actually is equal to x1, x2, and etc. xn and so on. But the x1, for example, x1 can repeat 2-3 times, x2 can repeat 10 times, doesn't matter. But we have to list down in the ordinary bracket, we have list down all the elements of the xn. Now with this one, xn, n from capital N, okay, we list down non-repeated xi, okay, non-repeated xn. Got it? The difference? For example, here you can see good example. There is it is this one, for this one, it is ordered list of values of the function x, some of which may be repeated, while this one is merely its range. This one is range now. This one is a range of xn. This xn is a listing all the elements. So for example, xn equal to 1, very nice example is given, xn equal to 1. In terms of bracket, it is 1, 1, 1, and etc. 1 and so on. But in terms of xn, Sn from n is just one number. It is the range. You can see if you draw the graph of this function, so n equal to 1, 2, 3, whatever value, you will have only one value, 1, 1, 1. So this one is a range. Range has only one value. Okay, the domain has actually is, look here, one that cannot go the next, 1, 1, 1. But in terms of bracket, we should list down. In terms of putting on the graph, we have 1, 1 actually. See, so this all repeating value is n. Actually, n here varies. Sorry, n varies. You see, so this is the dot is the value. Okay, but as a range, it is one, just one value. For example, another example here. In this chapter, we talk about the sequence. We generally mean the sequence of the real numbers. Okay, we are talking about the real numbers, and this is the often abbreviation. This is or like this or like this is the abbreviation. The sequence 1 1 is usually defined by giving the rule for obtaining its nth term xn. So actually, this nth term of xn is the nth term. For example, 2n is a sequence of even natural numbers, 2, 4, 6. Its range is n2, n sub 2. What does mean n sub 2? Huh? N sub 2 means it is a natural number which is factor of 2. So every value is a factor of 2. So n2. Okay, I think that there is nothing difficult to understand. And the second example, you see, this second example is nice. Example 2. If I take xn, look in the bracket, s minus 1 to the power n, okay? So now, in terms of n equal to 1, 2, and etc., this, what is this? If I open up this sequence, so when n equal to 1, it is minus 1, then plus 1, minus 1, plus 1. You see, the value minus 1 and plus 1, it repeats infinitely many. But as a range, I can write it is equal to plus 1 if n equal to 2k. It is equal to minus 1 if n equal to 2k plus 1. Okay? So as a brace we take as a range of the sequence. So you see, whose range is minus 1 minus 1 or minus 1, 1, 1 minus 1. Correct. This one, the sequence whose nth term is 1 over n. What about range? Okay, can you tell me the example 3? What about the range of this? And what about domain? So if xn is given like this, xn is given is 1 over n. You see, you can see this is 1 over n. 1 over n. Or if I list down, it is 1, 1 over 2, 1 over 3, and etc. 1 over n, and etc. So how do you think? What about the range of this? Huh? Okay, please tell me xn range. What about range? Hello, please help me. What about range? Is anybody understand the notation? This is the notation of xn, which is listing the elements. This is a notation which is showing the range of the sequence. So what about range? Hmm. 1, when n equal to 1, 1 over 2, 1 over 3, 1 over n, and etc. up to 0. So you see the range and the listing of the sequence is the same here. Okay, but of course, as a function, this is x, this is a y. Huh? So the 1, 2, 3, and etc. The domain is n, and value is from 1, 1 over 2, 1 over 3, 1 over 4, and etc. You see, it gets the dot, 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 which is okay. Understand that? So as a function, you can see it is decreasing function. Okay, now range is the same as listing of the elements. Okay, I hope you understand that. Now, sometimes sequence can be given like this. Now it is more complicated case. Next example. For x1 is given as 0, xn is given as 1 over 2, 1 plus xn minus 1. Okay. How n here, n starting from 2. So what about listing of the element of the sequence and whether the range? Okay, please solution a little bit. So x1 equal to 0, x2 when n equal to 2. So x2 is 1 over 2, 1 plus x1. x1 is 0. So it is 1 over 2. So n equal to 3, x3 is 1 over 2, 1 plus x2. 1 plus x2 is 1 over 2. So 3 over 2 square, right? Correct my calculation? One more. x4, 1 over 2, 1 plus 3 over 2 square. So it is equal to 2 to the power cube. So here 4 plus 3 is 7. 7. Or I can say, look, I can write like this. E to the power 2 minus 1. This is 2 to the power 2. So this one, 2 to the power 3 minus 1, 2 to the power 3. So in general, so now I can state that the nth term of the sequence. Okay, nth term of the sequence I can state. So when it is 4, this is 3. So if it is 3, so here n minus 1 minus 1. Okay, now you see from this equation, I find out nth element of the sequence. Now, can you show me the range of this sequence? Okay, where is the range of this sequence? Now, when I say the range, I will write like this. So, okay, n starting from 2, yeah, because it is stated n starting from the 2. So, what is the range n starting from the 2? Range is 0, 1 over 2, 3 over 4, 7 over 8, and so on. You see? So this is the range. Function value is 0, 1 over 2, 3 4 over 4, 8 over 7 over 8, and so on. So actually, this is a general scheme. You see, from the given formula, we can find the nth term. This is, we call it nth term of sequence. You see, from the given information we can find. Now, if actually there are two problems. One is if xn is given, you can find out the elements of the functions, elements or range of the sequence. That one is easy. You see, here very nice example is given. Next example, example 5. So xn is given as n minus 1 over n, and yn is given minus 1 to the power n. So solution. So the range of xn is, okay, when n equal to 0, n equal to 1, it is 0, 2, 1 over 2, 2 over 3, 3/4 and etc. What about yn? Yn. If I put like this, so I am finding what? Actually, first better find like this. It is better to find the listing the elements of yn. So when n equal to 1, it is -1, 1, -1. Hello? The internet stopped in my computer. Alhamdulillah. Okay, internet stop. So I think that Alhamdulillah, it is okay. So please pay attention. If I ask you to in the first sequence, you see, this is the listing of the elements, and this brace is finding their ranges. Okay, finding the range. So in the second sequence, -1, 1, -1, 1, even though the nth term of nth term un for every n is equal to 1, is equal to 1 and -1 is 1. No matter how large we take n, there will be terms that are not close to 1, namely the first term which is odd. Okay, so I hope you already know the notations, brace and bracket. So bracket is listing the elements of the sequence, brace showing the range of the sequence. Okay, so now you can see all this sequence approaching to some number, so means it is a convergence sequence. So how to understand the convergence sequence in the terms of mathematical definition? So this is very clear definition. A sequence xn is said to be convergent if there exists a real number x with the following property. For every epsilon, there is a n. Actually, this one should be, there is a cap n from capital, the natural number set, such that n greater than capital N implies this absolute value is less than epsilon. If xn is not convergent, then it is called divergent. So this is a convergence of the definitions. If there is no such capital N, such that this n greater than capital N, this inequality implies, such that implies this inequality, then xn from the first point is not easy to understand. But later on, if you understand very well, then you can handle many problems in the limit. Many problems you can handle it. So that's why please very carefully try to understand this point. So what does it mean? This, look, graphically I will explain. Actually, in my the year of the student, This one was one of the tough point to understand what is uh, the convergence sequence. Actually, in terms of limit, very simple. You see, this A is called limit of sequence xn. Okay, so if this limit exists equal to A, which is finite, we call it this one finite, then A is called limit of sequence xn. You see, in the limit definition, very simple, and epsilon, and not epsilon delta, epsilon n, capital N definition. It is says, you know, this one says, we have somewhere, we have the x point, and x1, look, x1 is here, x2 is here, and etc. xn is, you can see from the graph, it is approaching to the x from the left side. Actually, in R we have only 3 types of convergence. So this is the left side convergence. You see, this x n equal to A means this one A. This one is the A. You see, x1, x2, x3, and xn slowly approaching or fast approaching to the number A. So that's why this sequence is called convergent. If A is finite number, so then this sequence is convergent sequence. And now the second one, it can be approaches from the right side also, x2 and etc. xn. You can see xn approaches from the right side. And there is a case. So here we have A, but x1 starting from here, x2 is here, x3 is here, x4 is here. You see, x1, x2, x3, x4, next x5, x6, and so on. You see, it can approaches to the point A, spiral form of the spiral convergence. We call it spiral convergence sequence. Okay, we have in the real and real set, we have 3 types of approaches or the convergence: left side, right side, and spiral. Now, this epsilon definition, just I'm going to finish. Epsilon definition says, you see, for any epsilon, there exists capital N from this both N such that N greater than capital N. You see, this this N, what we call it, capital N, such that small n greater than capital N implies xn minus x less than epsilon. Okay, so this one means when you see epsilon is small number, when for small epsilon, all the values of xn, okay, all the values of xn lies epsilon neighborhood of x. You see, all the value of xn, if lies in the epsilon interval of x, or in our case here, this is the A. Instead of x, I should put A. Here. You see, the value of the xn lies on the small interval. A minus epsilon, A plus epsilon. Okay, so please try to understand this definition very well, and imagination also should be very well, otherwise difficult to handle the next problem. So all the values of xn lies in this small interval. So here two things, they exist small n, okay, exists small n. So n increases after some capital N. All the value of this interval actually lies around the A, densely reaching. So that is the point of this definition. Okay. Now I think next week I will properly teach the next properties and examples, how to find the convergence sequence by this definition. You see, epsilon definition. Limit definition is easy to find, just calculating the limit. But epsilon definition is a bit difficult. Okay. Anyway, so I'm going to finish with this one. So next week we will properly discuss, solve many problems. Then you will enjoy. I hope we can reach until the properties and conversion sequences. That's all. Any questions, any problems? You are welcome. So today 53 students attend. So no questions? Hello, no questions? Anne, no questions?
So far, no, doctor.
Okay. So in that case, finish today enough, I think. Already discussed the exams and so on. So please just revise and be ready for the next class. Thank you.
Yeah, there.
Doctor.
Okay. Can we
Thank you,
say
doctor.
bye-bye? Okay.